Hi everyone, my name is Amitesh, and in this video I'm going to rigorously prove that every repeating decimal is actually a fraction. So this is a fact that actually we take for granted right from the beginning of our math education, from elementary school in some sense. So here, for example, we have a repeating decimal. What this means is we have 25.82345713 repeated. So 5713, 5713, 5713 going on forever, where the bar above the 5713 indicates that. And the question is, why is this always a fraction? Why is this a ratio of two integers where the denominator is non-zero? And how would we even go about finding the integers in the first place? So this video, we're going to show this to you. We're going to go through it rigorously with a mathematical argument and also get the creative and simple trick, which I think is really beautiful and can be understood by anyone, no matter what your math background is. So let's dive into it. So here's the first motivation, is we remember the following kind of decimal, and the decimal is the following. The decimal is 0.333 ... So in other words, we would write 0.3 recurring. Okay, so we want to express this as a fraction. Now, we know this is 1/3, but the process we're going to use to do this will help us to find more complicated expressions where it's not so obvious. So what's the process going to be? Well, the process is going to be, let's call this x. Okay, so x is something we don't know. Okay, that's what we denote it by. We denote it by x. Now, here's the interesting thing. If we take 10 times x, we're just going to shift the decimal one place to the right. So instead, we're going to have 3.333 ... Okay, or which is equal to 3.3 recurring. Now, what happens if you subtract the 0.3 recurring, which was just x, from the 10x? Well, you get the 10x minus x is equal to 3.3 recurring minus 0.3 recurring, which is just going to equal to 3. And this is what's so cool, is this is some kind of like magical trick, but we know that 10x minus x is 9x, 10 lots of something minus something is 9 lots of the something, so we get 9x is equal to 3, which therefore means x is equal to 3 over 9, which is just 1/3. So this process is actually going to be the same idea we're going to do for other decimals, but let's actually figure out what it's going to look like. So before I do that, let me do one more example, which is going to be very similar to this one, and let's go for it. So what's the example going to be? So I'm going to now erase this, and I actually want you to think about, what you think, the fraction is going to be for the following repeating decimal. Try to work it out using the same process. Pause the video, work it out, because it really helps to come to grips and practice with these concepts. So now let's do it. So we've got 0.5713 recurring. Okay, so it's not quite the fraction, the decimal here, but it's part of it. It's a repeating part of it, right? We want to understand why that is a fraction. So why is this a fraction? Well, let's try the same trick. So let's call this x. Now the question is, what do we multiply x by to get something that sort of looks like x, that we can then do that subtraction trick we did earlier? So here's going to be the observation. We're going to multiply, because there are 4 digits here, we're going to multiply by 1 followed by 4 zeros. So 10,000. Okay, so we're going to say that if this is this, then 10,000 times x is going to equal to 5713. It's going to shift 4 places to the right. So we're going to get 5713.5713 repeating. Okay, so because it's infinitely repeating and going forever, it's kind of this weird thing that it just becomes the same thing again after the first 5713. There are an infinite number of 5713s. So if you move one of them to the left-hand side before the decimal, there's still going to be an infinite number of them. So what's really cool about this is, let's try the same trick. So if you got this far, try to work it out now. If you didn't get this far and you want to now see what x is, let's solve for x. So we'll do the same trick. So what is 10,000x minus x? Okay, so 10,000x minus x, so 10,000x minus x is just going to equal to this subtract this, it's just going to be 5713. So we kind of got rid of the decimals, made it an integer, and now what we can do is, we know that 10,000x minus x is 9,999x. Okay, so we're going to get 9999x, and therefore we're going to get that x is equal to 5713 divided by 999. And that's going to be our answer for that repeating decimal. So this is so cool. We not only proved that, mathematically, we not only proved that this is a fraction, a ratio of two integers, where the denominator is non-zero, but we also found what that ratio should be. And now, how do you do this though? Okay, so this is the next question. I want to sort of ask you a challenge. This is going to be the next challenge. How do you do that? But there's a clever trick we can do. So let's see what the clever trick is. I'm going to write it here. we can write this 25.8234, 5713, 5713, etc. We can just forget about the first part because we already know that's a fraction. So what do I mean by this? Well, we can write this is going to equal to 25.8234, which we already know is a fraction. Why do we know that's already a fraction? Okay, ask yourself that question while I go to the next point, plus 0.4 zeros, because there's 8234, 5713 repeated. Okay, so now if we can express something as a sum of two fractions, it's also going to be a fraction. So the first thing is, why is it 25.8234 a fraction? Well, 25.8234 is equal to 258234 divided by 10,000. Right? When you divide by 1 followed by a certain number of zeros or a power of 10, you move the decimal 4 places to the right. So you're just going to get 25.8234. And now this question is, why is this a fraction? Why is that a fraction? We know 0.5713 repeating is a fraction. Why do we know that this is a fraction? Here's a quick trick. Here's a quick trick that will help us, is that we can observe that this is going to be 5713 repeating divided by 10,000. Because when you divide by 10,000, you're moving the decimal 4 points to the right, so you get the extra 4 zeros, and we know that this is a fraction. We have proven this on the right side of the board. So therefore, if we know that's a fraction, we can get a fraction for this ratio, and then we can add on with this fraction to get another fraction, and that will be the fraction for this. Now I want you to drop a comment down below, what is the actual answer? You know, I've written out as something plus something, and I've said both of those are fractions. But what is the actual, like, simplest form of that fraction, like a over b, where a and b are integers and b is non-zero? Drop a comment down below to get that. And now you see the process works whenever. You know, whenever I have a repeating decimal, I just take the part that is non-repeating at the beginning, add that on to something that's repeating, and if I divide that by a sufficiently high power of 10, you know, I can get some repeating thing. I can divide that by sufficiently high power of 10 to get the repeating part of the fraction. Okay, same process as we did here. So thank you so much for watching. I hope you loved that video. I hope you loved how I try to make math super accessible and fun for everyone. You know, this video does not require any math background to understand. You know, I've introduced all the concepts from scratch, and that's how I try to make every video on my channel. Some videos are more advanced than others, but my goal is to create free accessible math education, infinite elite math education at all levels of math. And if you want to support my vision and, you know, help me to grow my channel and to support and help as many people as possible, please spread the word to friends, family, subscribe, like my videos, share them. You know, if you're working in high school, middle school, college, wherever you are, share with your friends. You know, let them know that math can be cool and fun like this. And there are maths at all levels. If you subscribe, you'll constantly be notified. It's like a cheat code. And I'm wishing you all the best. I'm here to support you. You know, we're on this journey together. I'm wishing you all the best for happiness, productivity, success, good health, everything. I want to support you in this video. And I'm super excited to see you in the next video. So I'll catch you next time. And please have a great day, evening, or night.